Today, we are going to discuss about the difference of two squares. We have two objectives for the day. The first one is to identify whether or not an expression is a difference of two squares. And the second one is to factor the difference of two squares completely. Before we start the lesson, let's have first a review. Tell whether the following number is a perfect square or not. We have here number 9. Number 9 is a perfect square because number 9 has a factors 3 times 3. Perfect square means you have a certain number has a factor multiplied to itself. Okay, now let's have number 2. 60. 60 is not a perfect square because there is no factor that can be multiplied to itself and the product is 60. So 60 is not a perfect square. 25 is a perfect square for number 3 because the factors of 25, one of the factors rather, is 5 times 5. And number 4, 120 is not a perfect square. Number 5, 81 is a perfect square because of 9 times 9. Because of the factors 9 times 9. And the product is 81. And that makes 81 a perfect square. Number 6, we have 40. 40 is not a perfect square. Number 7, 144. 144 is a perfect square because one of its factors is 12 times 12. 12 times 12, the product is 144 and it makes 144 a perfect square. Now let's have number 8. Number 8 we have 75. 75 is not a perfect square. Now let's proceed to number 9. Number 9 we have 49. 49 is a perfect square because of the factor 7 times 7. The product of 7 times 7 is 49. And that makes 49 a perfect square. And the last number is 54. And 54 is not a perfect square. Now let's have the activity number 2. Rewrite each number in exponential form. Okay, we have here 9, 144, 25, 81, 64, 100, 16, 36, 49, and 129. 121 rather. Now let's start with number 1, which is 9. The exponential form of number 9 is 3 squared. 3 squared because when you expand 3 squared, that becomes 3 times 3. And 3 times 3 is equal to 9. Okay, now let's have number 2, 144. The exponential form of 144 is 12 squared because when you expand 12 squared, that becomes 12 times 12. And basically, 12 times 12 is equal to 144. Okay. Now, let's have number 3. Number 3, we have 25. And 25 has an exponential form of 5 squared. 5 squared because, again, when we expand 5 squared, that becomes 5 times 5. 5 times 5 is equal to 25. Now, let's proceed to number 4. Number 4, we have here 81. The exponential form of 81 is 9 squared. Because, again, when we expand 9 squared, that becomes 9 times 9. And 9 times 9 is equal to 81. And And let's proceed to number 5, which is 64. 64, the exponential form of 64 is 8 squared. 8 squared because when we expand 8 squared, that becomes 8 times 8. And 8 times 8 is 64. Now let's proceed to number 6. Number 6, we have here 100. The exponential form of 100 is 10 squared. 10 squared because when we expand 10 squared, that becomes 10 times 10. And 10 times 10 is 100. And down to number 7, we have 16. And 16, the exponential form of 16 is 4 squared. Since 4 times 4 is equal to 16. Yes. Now let's proceed. We're almost there. We have here number 8. Number 8, we have 36. The exponential form of 36 is 6 squared. 6 squared because 6 times 6 is 36. And number 9, we have here 49. The exponential form of 49 is 7 squared. Since 7 times 7 is equal to 49. Yes, and to the last number that we have here, it is 121. The exponential form of 121 is 11 squared. 11 times 11 is simply 121. That is why the exponential form of 121 is 11 squared. Now let's define the difference of 2 squares. The definition states that if x and y are real numbers, variables or algebraic expressions, then the symbol for difference of 2 squares is x squared minus y squared. The difference of 2 squares is the product of sum and difference of those terms. In the third table or chart, we have here x squared minus y squared is equal to the quantity of x plus y multiplied to the quantity of x minus y. X squared here is our first term, and y squared is our second term. And these two quantities are our factored form. The factored form is what we are hoping to achieve in factoring the difference of 2 squares. Now let's have the first example of factoring the difference of 2 squares. Okay, now we have here the given x squared minus 25. First step is to get the square root of the first term. Our first term is x squared. The square root of x squared is equal to x. Step number 2, get the square root of the second term. Our second term here is the 25. The square root of 25 is equal to 5. And finally, we're going to write the square roots as pairs of conjugates. Okay, we have here the quantity of x plus 5 times the quantity of x minus 5. Since conjugates means that there are some features in common but has differences in particular. We did write the first term, the square root of the first term in each quantity, and the square root of the second term also in each quantity. The difference that it makes is the sign or the operation separating the two terms. You have positive and negative. Now let's have example number 2. Example number 2, we have here 16a squared minus 100. Again, the first step is to get the square root of the first term. Our first term in this example is 16a squared. And the square root of 16a squared is equal to 4a, because the square root of 16 is 4 and the square root of a squared is a. Now let's do the second step. Get the square root of the second term. The second term for this example is 100, and the square root of 100 is 10. In the last step, write the square roots as pairs of conjugates. We have here the quantity of 4a plus 10 times the quantity of 4a minus 10. Now let's have example number 4. Example number 4, let us factor 36x squared minus 81. First step is to get the square root of the first term. The first term is 36x squared, and the square root of that is 6x. Step number 2, get the square root of the second term, and the square root of the second term is 9, because the square root of 81 is 9. And the third step is to write the square roots as pairs of conjugates. We have here 4a, the quantity rather of 4a plus 10 is multiplied to the quantity of 4a minus 10. Let's have example number 5 in factoring the difference of two squares. The given for example number 5 is negative 64y squared plus 36. Before we start the step 1 or the usual step 1 that we do, let us first rearrange the terms that shows subtraction as the operation separating the two terms. It becomes 36 minus 64y squared. Then, we can start step 1. Step 1 is to get the square root of the first term. The first term here in our example number 5 is 36. And the square root of 36 is 6. Okay, now let's proceed to step number 3 for this example. Get the square root of the second term. Our second term here is 64y squared, and the square root of 64y squared is equal to 8y, because the square root of 64 is 8 and the square root of y squared is y. And the last step of course is to write the square roots as pairs of conjugates. We have here the quantity of 6 plus 8y times the quantity of 6 minus 8y. This factored form is our answer for example number 5. Let's have example number 6. Example number 6 is 18y squared minus 32. As you can see, both numerical coefficients of our expression is not a perfect square. To make it a perfect square, we are going to look for the greatest common factor of the expression. We are going to get the greatest common factor of the expression. So 18 and 32, upon investigating, the greatest common factor of the two numerical coefficients is 2. And the expression becomes 2 times the quantity of 9y squared minus 16. And since 9 and 16 are both perfect squares, we can now proceed to the next step. Step number 2, get the square root of the first term. Our first term here is 9y squared. And the square root of 9y squared is 3y. Yes, because the square root of 9 is 3 and the square root of y squared is y. And let's proceed to step number 3. Get the square root of the second term. The second term here is 16 and the square root of 16 is 4. And lastly, we are going to write the square roots as pairs common factor 2. We're going to write both square roots as pairs of conjugates, but we are not going to forget the greatest common factor 2. And the factored form becomes 2 times the quantity of 3y plus 4 times the quantity of 3y minus 4. We are now down to the final example that we have for the day. And our given is 4ab squared minus 9a. 4ab squared minus 9a basically does not meet the conditions that we have set in factoring the difference of two squares. The first condition, if I may recall, is that there are only two terms in the expression, and condition number 1 is fulfilled. Now let's proceed to condition number 2. Condition number 2 states that the numerical coefficients of the expression should be or must be a perfect square. And since 4 and 9 are both perfect squares, then condition number 2 is met. Now let's proceed to condition number 3. Condition number 3 states that the exponents of the literal coefficients must be even. And we have here the literal coefficients for the first term are a and b. The exponent of a is 1 and the exponent of b is 2. Since the exponent of a is an odd number, therefore condition number 3 is not met. But in this case, the first term has the variable or the literal coefficient a, and also the second term also contains the literal coefficient a, and it has the same exponents of 1. So we are going to get the greatest common factor of the expression. The greatest common factor rather of the expression is a, and that expression becomes a times the quantity of 4b squared minus 9a. Since we have now an expression that meets the conditions of factoring the difference of two squares, let's proceed to step number 2. Get the square root of the first term. Our first term here is 4b squared. The square root of 4b squared is equal to 2b. And step number 3, get the square root of the second term. Our second term here is 9. And the square root of 9 is 3. Now let's proceed to the final step. Write the square roots as pairs of conjugates. We're going to write 2b and 3 as pairs of conjugates. But in this case, since we have the greatest common factor, we will include this in our factored form. The factored form of this expression is a times the quantity of 2b plus 3 times the quantity of 2b minus 3. Here are some exercises that you may want to do on your own. Factor completely all the expressions presented on the screen. There are 10 expressions. You can do it by following the steps or the examples given in the video. Thank you for participating in this video. I hope you learned something, and you may want to share your ideas or suggestions on the comment box below. And see you on my next lesson for another time. Adios!